So today we are going to start with the chapter 1. It's real numbers. While learning that, you should know about what you mean by a composite number and prime numbers. Okay, so what do you mean by a composite number? Composite numbers are numbers like, for example, 4, 9, 50, even 10. These all can be called as a composite number because composite numbers are the numbers which have the factors more than 2. A number 4, it have how many factors? What are the factors of 4? 4 can be written as 4 into 1 equal to 4. 4 in, then what? Then 2 into 2 equal to 4. So what are the factors from here? The factors are 1, 2 and 4. If you're checking here, you can see that among them both, this 1 and 4, this is the number 1 and the number itself, right? Similarly, for every number, it always have two factors as common. One is the number 1 and the same number. But the numbers which are having the factors other than them both means a third factor, it's called a composite number. Okay, and if that's a composite number, then what will be a prime number? Prime numbers are the numbers, for example, as I told first, prime numbers like, for example, 2, 7, if I'm writing 13, 19. What are the factors of 2? 2 only have what? These two factors. What are the factors of 2? The factors of 2 are 1 and 2. If I'm writing the factors of 7, means it have only how many factors? 1 and 7. That means 1 and the number itself. These are the two factors. So prime number always have how many factors? Exactly 2 factors, where one among them is number 1 and the same number itself. Now you understood about what you mean by a prime number or what you mean by a composite number, right? So now let's go to the theorem 1. I first explained here about the composite numbers and the prime numbers. Now to explain these things. Every composite number can be expressed as a product of primes, and this factorization, it will be always a unique, means apart from the order in which the prime factors also. Okay, for example, if you're looking at the number 6, how I can write the number 6? 6 can be written as, means here if you're checking, 6 is what? 6 is a composite number. 6 can be written as a product of what all numbers? 2 and 3, right? Another way I can write the 6 is 1 and 6. So if I'm checking here, 6 is again what? Every composite number. It can be expressed as a product of primes. Look here, 3 is a prime number, 2 is a prime number. And if you want to factorize it will have only a particular way of factorization. Okay, right? If I'm writing the number called 231, if I'm finding the factors, if I need to factorize it, I can factorize it using the 231. For factorization, its factors are 3, 7, 11. Okay, so if you're looking at here, you can see that 3 is a prime number, 7 is a prime number, 11 is a prime number, 231 is what? It's a composite number. Okay, so now let's move on to the exercise 1.2. In exercise 1.2, they are asking us to express each number. Every number we have to represent as a product of prime factors. So if I'm taking the number called the 140, I can divide it, the least number with which I can divide the 140 is what? 2, right? So what I will get? 7 2s are 14, so it is 70. Again, if I'm dividing, since the last number, ending number is 0, We have learned in the previous years that if the ending number is 0, that number is divisible by 2. If a number should be divisible by 2, it should have either 0, 2, 4, 6 or 8 in the final place, or means in the last, as a last digit. Either if anyone among them is coming, we can tell that it's divisible by 2. So 140 by dividing I will get 70. 70 again I can divide it by 2. So what I will get 35. Now 35 is not further divisible by 2 because here the ending number is 5. A number, first we can check whether these are divisible by 3 or not. How to check it divisible by 3 or not? Now we can add them, the digits. 3 plus 5, we are getting 8. 8 is not coming in the multiplication table of 3, so we can tell that it's not divisible by 3. Now so we can go for the 5. 5, any number ending in 0 or 5, it means that is divisible by 5. So the next least prime number with which I can divide this 35 is 5. Now what I will get here, 7. As I all know that 7 is only divisible by 7, right? So what are the factors? I can write this 140 as 2 into 5 into 7, correct? Again, this can be like, how many 2 is repeating here? That is 2 raised to 2 into 5 into 7. This is its answer. Okay, understood? Now next one, 156. How to do the 156? Again same like this, we can do the 156. Since the last ending digit is 6, I can divide it by the least number with which I can divide is 2. So I'm going to divide it with 2. I will get 7 2s are 14, remainder 1 16, so it is 8 2s are 16. Then again I can divide it by 2. I'm dividing it by 2, I will get 3 2s are 6, remainder 1 18. 18 means 9 2s are 18. Now if I'm checking here, this number, what is 9 plus 3? It is 12. So the least number with which I can divide the 39 is 3. With 3, when I will divide this, I'm going to get 1 3. 13 is a prime number, so further division is not possible. So I have to write 13 here. So what are the factors of 156? It is 2 into 2 into 3 into 13. So again, if I want to rewrite this again, I can write this one like 2 raised to 2 into 3 into 13. Okay, now moving to the next one, it is 3825, means 3825. How can I do that one? 3825. If I want to check whether this is divisible by 3, what I need to do? 3 plus 8 plus 2 plus 5. What I will get? 8 plus 2 10, 10 plus 5 15, 15 plus 3 18. 18 is divisible by 3. 6 3s are 18, right? So that means this number, it is going to be, I can divide it by 3. On dividing by 3, I am going to get 1 2 7 5, correct? Okay, 1 2 7 5. Okay, then again I can check whether it's divisible by 3 or not. What is 1 plus 2? 3. 3 plus 7? 10. 10 plus 5? 15. So it is divisible by 3 again. On dividing it by 3, I am going to get 4 to 5, correct? 4 to 5. Again, if I'm checking whether it's divisible by 3 or not, for that I have to add them all. 4 plus 2 is 6, 6 plus 5 is 11, so it's not divisible by 3. So I'm moving to the next number with which I can divide that. It's 5. So on dividing it with 5, I'm going to get 85, correct? This again I can divide it with 5. On dividing it with 5, I will get 1, a reminder, 3, okay, 7, So 35. So 17 is a what? It's a prime number. So I can only divide it with the 17. So I'll get the 1. So how to write this one? The factors are 3 into 3 into 5 into 5 into 17. This again I can rewrite like how? That is 3 raised to 2. How many times 3 is getting repeated? 2 times. Similarly, how many times 5 is getting repeated? It is 2 times. 5 raised to 2 into 17. Okay. Then comes the next one. 5005. 5005. 5005. Again, if I'm adding them both, I'm going to get 10. 10 is not coming in the multiplication table of 3. So I will have to move with 5. On moving with 5, I'm going to get 1, 0, 0, 1. Okay. Again, this one, what I can do, I can only, if I'm checking here with the 3, it's not possible because 1 plus 1 is 2. It's not coming in the multiplication table of 3. So I'll have to move it. The 4 will not count, then 5 will never count. Okay, now it's a 7. 7 means 1, 4, 3. Okay. Again, 143 means I can divide it with, check with all numbers how I can divide, with which number I can divide 143. With 9 it's not possible, then 10, then okay, 11. 143 with 11, if I'm doing, what will happen? 1, 11 comes here, 3 comes here, and this 3, what will happen? 3 here, 33. So if I'm dividing it with 11, I'm going to get what? 13. Okay, 13 I can again divide only with the 13 itself, right? So what I will get here, the number I'm going to get here is 5 into 7 into 11 into 13. But if you're observing here, there is no similar digits are not coming, and your repetition is not happening here. So these are the factors. We can just write it like this itself. 17, 5 into 7 into 11 into 13. Okay, good. Now next comes the number 5, right? In the 5, the question was 7429. 7429. The least number with which I can divide the 7429, it is 17. If I'm dividing 7429 with 17, I'm going to get 437. Again, on dividing, I need to use the number 19. I will get 23. 23 is what? 23 is a prime number. With 23 only I can divide it. Okay. So this is the answer for 7429.